Cool. All right. Hello, everybody. Welcome to the Neo4j Online Meetup. So, for those of you who haven't joined us before, if you have any questions, don't forget to ask those on the live chat on the right-hand side, and I will pass those on to the speaker when there's a bit of a gap for me to do so. There'll be a presentation part of showing some code in the presentation, and so for that you'll want to make sure your resolution is high enough, and you can do that with the little cog icon on the bottom of the YouTube player, so set that to 720p or higher. With that, I guess I'll introduce our speaker. Well, there's a couple of us from the Neo side, so my name's Mark, in case you haven't met me, so I work in the developer relations team in London. And then I've got my colleague, Will Lyon, and Ward Cunningham with us today as well. So I guess I'll let them introduce themselves. So maybe, I guess Will, you can go first, and then Ward can go after.
Sure, thanks, Mark. Hi, everyone. My name is Will Lyon. I work with Mark on the developer relations team at Neo4j. I work on helping users build applications, building integrations, and things like that.
And I'm Ward Cunningham, and I've been a computer programmer for a long time and never kicked the habit. I still proud to call myself a computer programmer and be allowed to program too. So that's it's been a good life. And somewhere along the line, I, in support of those of us who were trying to kind of change the literature of computer programming, cooked up this thing called Wiki, which is had some legs. I just love it that when people talk about all the things that are wrong with computers, they stop complaining about Wiki. But I've found Neo4j a couple of years ago and kind of feel that it has a lot of the feel of collecting things together that is an ensemble of stuff, and have adopted it internally at my company, where I'm work with a team of architects, and we have to have a comprehensive view of things, and like the way that you can write precise queries against the graph, which is different than roaming around a wiki or any other kind of database. So it's something I feel a little embarrassed here amongst all the experts, because I'm still consider myself a beginner, but it's been a great ride so far, and I, found the community edition lets me be part of the community, and I'm when we open source some stuff, I finally said, well, my company said I can talk about it implicitly by open sourcing it, so here I am. I'm looking forward to become a better part of the community.
Cool, and I think it's about, you said it was about couple of years, was it 2016 or so, the first time you did some Neo4j stuff?
Yeah, I was learning it before we started on this current project. In fact, I recommended it to a colleague, and it might have been 3 years ago. Now I would have to check the date. But I actually ran into Michael Hunger at the OOP conference in Germany, and he I'd mentioned casually something about graphs that we were doing in federated wiki, and he sat down and wanted to hear about it. Slipped me some swag, and
always the swag.
Yeah. Well, that's when you that's when you know that you care, is when you keep the stickers, right? And so it was casually mentioned. We did a big reorg. We're a growing company. We were a small company. We became a big company, and turns out everybody was waiting on everybody else to do something. It was kind of dueling priorities. And so we just re-engineered the whole company. The engineers re-engineered the whole company, and then we said, let's have a big festival, and everybody will kind of pick which team they want to be on. And once every team was suitably equipped, then we called the day done. And so it was a massive reorg. And part of that was we also made a commitment to do, if you were on a team that supported other teams, you would do it by self-service. You wouldn't ask them to put their needs on your priority list. You've already built something so they can use the support you provide self-service. And that made for a lot of stuff being, kind of API driven, or and that was really when we started saying, okay, well, how's this going to work out? We need to keep an eye on this. If you can make all the services you want, what about the ones you forget? How could you forget? They're still in production. Does anybody use it? Who owns it? That guy left the company. What's going on here? And that kind of detail as we, I suggested, well, you could put that in a Neo4j graph. And my colleague said, well, okay, that sounds interesting. I came back the next day and I said, well, forget what I said that. That was that's a sledgehammer. You don't need a graph database to answer this simple question of what's left behind. And he said, too late, already did it. And I said, oh, great, let me see it. And it turned out it was fascinating. We merged 3 different sources of information, and we could kind of browse around through it using the browser module and Neo4j, and we were hooked.
And is that what you see as a real benefit of Graph and Neo4j, like just being able to merge in several different data sources and query across them? Is that a big benefit?
That was number one for us, and we weren't very good at it, but we had data sources that sort of fit together, and so they were different programs, and nobody owning one program or the other programmer wanted to kind of read each other's data. So we'll read everybody's data. And the modeling was pretty simple because a service was a service and a team was a team. They used the same language. Eric, gosh, I forget, the domain-driven design, I feel terrible. Eric Evans, calls that a ubiquitous language. We were operating within the space of a ubiquitous language. And as we've gotten further and further away, I noticed that my schema has regions in it. There's the stuff that's all about, getting the software written. There's this part that's about planning what we are going to write. There's the part that's about, keeping the operational stuff running. And I showed that to Eric, and he says, yeah, those are called bounded contexts. And you have a bounded context map. And I went, whoa, that's amazing. What's a bounded context map? And Eric said, well, it's in my book. You should know, you reviewed the book for the publisher. And the funny thing is, I remember reviewing the book, and these are the later chapters. And at the time, I thought, well, once everybody learns how to refactor, they'll all speak one universal, ubiquitous language. And that, Eric knew more than I did, and that wasn't going to happen. So what we did is, he has a lot of patterns about how do you take the terminology here and make it work with the terminology there. And I was just trying to get an overview, not even actually move the data around and transform it, but just sort of say what talks to what. And the model, the schema of the graph, when I finally got all the pieces together with, I think at that time I had about 10 or 12 sources, and this emerged, this picture of all the different ways we talk about things. And, there would be little clusters where, of course, all these different things are talking about the same thing, and then a different cluster over here. Now we're running about, I think yesterday we just added our 35th service that is providing data into our graph. And, we really kind of say, well, what else hooks this thing to that thing to that? So we've sort of mushed it together, but there's a modeling aspect. And this is something that, if your data is already modeled, you kind of understand it. But if you have this stuff that is sort of, let me say, casually modeled by the engineers that were solving a local problem, and I pull their structure information out of that, then I have to translate it so it all fits together, and that's a modeling aspect, which is, it took me a while to learn, and I wouldn't say I'm an expert at it yet. We're pretty quick. If you have some data, we're pretty quick to put it into the system. And biologists, if they discover some new protein, they get some stupid name and a 3-letter code. So that's what we do. We say, oh, well, we don't even, you have this thing you call a service, but it's not what we call a service. So we're going to call it something else, SVS or something. And it lives in the graph there until we figure out how it works together. But figuring it out, it's nice to have, Cypher and browsing and, to look at how it fits and how it doesn't fit and what we might have to do to actually merge things in.
So is the idea there that you're sort of monitoring all of the microservices that exist in the organization, how they interact, and the dependencies among them? Is that sort of the general idea?
That's a large part of us because, like so many other companies, we've really, embraced that. And my data is about, like none of that microservice data flows through my system. But if we deploy services based on some structure of how they're supposed to work together, I say, well, your computer knows how they're supposed to work together. Just tell me what you know. Give me your sense of a diagram. We also instrument that sort of stuff, so some of it comes out of our own instrumentation. But I don't hesitate to use any kind of source of any kind of, some stuff is, up to the minute. Other stuff, it could be 2 weeks old from the last time the architects reviewed it. And, that variability. One thing we get to a lot is we'll say, okay, this is in the graph. Why is it in the graph? Who put it in the graph? How much do we trust what went into the graph? And there's a lot of tracking down of variable quality data. And my ability to do that actually helps people bringing up some new system. Oh, we're going to build a system that'll keep track of this for corporate compliance or GDPR or something like that. They say, well, we need to have a database of all the X's and the Y's and the P's and the Q's. And I said, well, I've got X's and Y's and P's and Q's, but it wasn't designed for that purpose. So they build something and I say, well, I'll just check it. I'll read your data. And while you're building your system, populating it with what you think is right, I'll tell you how it agrees with other things. So, and they say, well, why should, so all of a sudden I'm inserting myself in other people's jobs. And I say, well, I'll be your QA department. And nobody turns down QA, right? I say, well, I'll just check what I hear from other programs floating around in the company with your program, and I'll tell you how it lines up, or where it doesn't line up. That's more important. I started this thing explaining to my boss what I was doing. I said, well, I want to build a tool that all of the architects, and at that time we had probably 10 or 12 architects that would be distributed around the company that met together occasionally as a team. And I said, I want to equip them with a model that, goes outside of their area of expertise, because as an architect, they should really understand the whole system. And, that's worked pretty well. Architects are more inclined to clue me into some data source that is missing and help me get it. But it's also turned out to be important for our site reliability people, reliability engineering. It's also turned out to be important for security. Security will run some sort of scanner and get an alert based on an IP address. And they say, I need to convert an IP address to a Slack channel. Well, it goes through quite a few layers to get from IP address to Slack channel. And plus, there's probably 5 different teams keeping track of information, but we can do it. And that keeps, keeps that process working.
That's neat. So you spoke a little bit about how you've open sourced some of the pieces of this tooling that you've been working on. Could you speak a little bit about what pieces you've open sourced and sort of how those are used?
Yeah, I'd love to do a little demo, but first let me explain kind of the approach we used. I mean, the Neo4j browser application was great for us, and we would develop queries, and I said, well, that was a nice query. It draws a beautiful picture. We should save that. It's the Cypher, and so we'd paste it. And, we had a page that had 15 useful queries, and they were growing 2 or 3 a day. And I said, well, this is a problem. So we wrote a little application that would run the queries for you. It was a Rails app, and it turned out the way Rails worked, I had to edit 3 different files for each new one. And Then I asked the Rails expert, I said, well, why don't you look at the way I'm using Rails and see if there's a better way to do it. And she looked at it for half a day and she says, all this stuff that you're doing could just be in a YAML file, and then we'll just write a simple little Sinatra app to to run them. And she did that for me. She threw the whole Rails thing away and made this nice little simple thing. And all of a sudden it became very powerful, because if I found, I think at that time it might have been about 30 queries. So if query number 25 pulls up 5 different columns of things, maybe a team name and a system name and an IP address or something like that. If you click on anything in that column, I wanted to go find the query that needed that as a parameter. And if I was looking at the 25th query, I start there at 25 and 26 and 27 and loop around looking for a query that needs a team name or a service name or an IP address. And so things just automatically linked. And that was the other chore I had, which was how to drill down into things. And we just made it automatic. And that had we also tried to do a recommender, and the recommender didn't work quite. If you're doing this query, you ought to try this query, and that didn't work as well. But we weren't skilled at that. But
interesting. So it's not just about sort of running one query ad hoc. It's more about being able to explore the graph and sort of selecting from different queries to explore different pieces of the graph. Is that the idea?
Yeah. So it's the answer to every question just raises more questions. And so we just said, well, okay, that was a nice query and it shows us something, but now that we look at it, what's going on here in column 3, line 15? Who is this thing? And you just want to click on it and then have a query that's made for it. Well, as soon as you have that capability, you say, oh, let's write that query too, or some other query. And because they're all kind of based on the vocabulary, the labels that we attach to nodes, and we use those as column heads. And when you click on something in a column, you say, well, we know what it is because it has a column head on it, and that column head is the label that's a node in the database. And so it all kind of holds together. So we were sort of, in a sense, projecting into our collection of queries knowledge about our model. And that has played out well. But let me can I do a little?
Yeah, I'll give you the control.
Okay, I'm presenting to everyone. Now, do I have to say screen share here, I guess?
Yeah. Okay. On the left-hand side, second row down. There we go.
It's called El Dorado. This was our top-level menu. It says, here's some different queries that you might want to use. We saved down here for ourselves our kind of favorites. Here's like a list of all the sources. These are different things we read when we last read it, what's about it, different links into different things that we could get from it. And this is one that was added. New project called Project Galileo is about service SLI, service level indicators or something. This is just where we're using our own alerts mechanism to match what we do. So I clicked on that and it says, okay, let's match for all the nodes that are in a relationship. In this case, the source was from Galileo, here the parameter, and it just finds them and draws a picture. So there's a lot going on there. So these are nodes, these are the relations between them, and these are the sources. Galileo is just one source, and how many of those relations we have. So this is telling us kind of what we had. Now I was thinking I came over here for a purpose, and all of a sudden I got caught in a demo here. Now what? Help me! What's the curious thing about this? I guess I showed you that I could pick something. Like if I pick, we have this thing that we built after this, the team information was missing, so we didn't have a good store. So we developed this thing called Team Store. It just describes all our teams. If I click on that, this is all the ways that.
So is this a graph of all your colleagues? Is it, or a metagraph?
This is a graph of what we know about colleagues.
Okay.
Like people. Here's a person, and a person could be a member of a team, or it could be a leader of a team. You know, it might be scary that we have more leaders than we have members. Well, that's because we don't tend to share members between teams, but we do share, you know, because this could be, like I'm an architect, so I would be a leader. I would be one of the 454 for several teams.
And is that extracted from like Slack or some other system?
Well, Team Store is something we built. We had all that information in a wiki, and I would scrape the wiki, and that was a nightmare. And I just said, we need a reliable system. So that was one. But if I want to know more, if I want to say that was just some source, if I can, and you can see I say, you know, I'm just doing a query here, and I pull up, you know, all the relationships from the source. If I click on team, I say, show me all the relationships that touch a team. So now I'm saying, you know, and here I want to either end of this relationship where the head matches or the tail matches. And then you know, not surprisingly, we have a lot of different things that hook up to teams. And you know, if I want to talk about people, what do we know about people? I can click on them too. And we're sort of, this is avoiding drawing the whole schema because it's too big. But the other thing that's important is that we remember where we learn things. You know, so we merge a lot of information together on a person or a team, but it comes from different places. So for just about people, we have 1, 2, 3, 4, 5, 6 different sources of information that talks about people one way or another.
And here you also track like the provenance of the data as well. I see like got Team Store in the middle and Workday on the bottom left.
Yep.
Is that stored in the graph as well?
Yeah.
Oh, cool. Okay.
So when we first started, we said, well, every node will have a relationship with its source. And that turns out that whenever you went browsing around, you kept bumping into sources and it'd tell you everything. So we decided to I make this a dotted line thing. It's not really a relationship. It's just that I keep track in the database of all the different sources, and they have names, and I just, in every relationship, I just tag it with a string, which is the name of the source. And that way the graph is really about the structures I get from different sources, but this is my metadata in a sense. You know, here's how many departments. We have 1,277 former employees. Let's just drift away from that. Maybe that's not too, you know, I actually have to be careful. All this data is, we all agree it's company confidential. We never put anything in here that is higher security than company confidential, but it is all company confidential. To that end, here's another version. This is a much simpler version. It's all filled with fake data. And if you want to know what's in here, I can just click. And this is small enough that I can say, show me everything. So here I have programs that are instantiated into production or staging that support a project which has a manager who's an employee, and there's people work on it, and the program starts. So I have 1, 2, 3, 4 imaginary sources here. And this is something that I can share with people who want to do this. They can say, okay, I understand what you're doing here and how you get this data built. So this is something. So like if I want to say the data, like I could say, here's a team that has employees. Show me what those look like. So there's 476 of them. And if I click on that number, I just say, well, here they are, 476. I actually pass in what the count was. And if it's over 100, then I do some sampling here. Random. Let's see if I look at that whole thing. So I have the count, and it says if random, so there'll be about 100 samples. But it's good to look at the data to see what kind of things you have in here. So a program has a description. All these are manufactured descriptions. Some of them are pretty good. Gamma root mean squared deviation between two protein structures.
Sounds pretty real to me.
Well, I think I just asked Wiki. I said, give me a list of programs. There's some table, list them of programs or something. All manufactured names, stuff like that. But here the relationship is a team relationship, and it's tagged with a source. So here's the tag that I use to get that information. So this is the, oh no, I just bumped something. I don't know where it's going, but that can't be right. Let's see. This is where I wanted to be, yeah. So,
So we had a question for you from Samantha, who was asking, what are you using to display the graph visually? I guess maybe that meaning like what tools or libraries did you use to create it?
Yeah, that's an excellent question, and Neo4j browser does a fabulous job of looking at whatever you find. It can render pretty much anything. But and there was a nice, I'm trying to remember who wrote it, but they said, well, there's small graphs, and there's medium graphs, and there's big graphs, and there's huge graphs. And so I think we have a big graph, and we want to pull out of it small graphs that we can draw. And we're using GraphViz, which is actually a very old program, but it tries very hard to do both placement and routing. It kind of draws graphs the way people draw them. And if you have a small graph, it works. If you have a big graph, it just turns up into rivers of lines. So what we'll do is we'll write a query that makes it into a small graph. And I'm going to switch back to screen sharing again so I can look at how that's done. And
yeah, I think what is quite interesting is that it looks obviously quite different to what, like for example, I guess the one people are really familiar with is D3 with its force-directed layout, and they're used to like the nodes all like trying to repel or attract to each other, and so you end up with something that looks completely different than this one, which looks quite, or this looks really quite organized and quite structured.
Yes, and I'm a big D3 fan, and I was heavily into D3 from the beginning and kind of learned how all that works. I know that Neo4j has some D3 experts because your stuff is great. But here's what we did. We, this much is cipher, and we're basically answering, we do some simple match with a where clause or with clause, and then we just start counting things and pulling out the types. We produce a bunch of columns, and they're down here. It shows us what the columns we got were. But then the GraphViz format is called dot, and we just say, okay, now we're gonna take something that will render those columns. And remember, our columns are count and from and regex and source and to and type and special. Special means it should have a different color. Sometimes these are so big that identifying a few key things just by color is fine. Then it has some kind of how to do things generally, work from left to right. We're going to draw things as boxes. If it's special, make it color gold. But then we end up with something like we say from to, well, here we're saying from of a type and a to. So this is a relation. The from address, the type, and the to all combined together. That becomes a node. And then when we show it, we're going to show it with just the type. But the type, you know, read or team or some of these numbers could appear multiple times in the graph. So we identify it, and so this is you know, all this stuff. This is our version of parameters, not Cypher's version of parameters. We make it look the same way because we're taking the output in columns and turning that into a GraphViz program. And GraphViz has things like, oh, if you attach a URL to something, where is it? There's got to be
second line.
Here it is, URL. Right. This is how we get that drill down to work. Is we say, oh, if you click on this, and here it actually refers to the same graph, but with different search conditions, different where clauses. And
this
so
kind of just renders the same thing, but with some different parameters.
Yeah, and I think that, let's see if this works. If I say dot slash, yeah, so that's what it generated. Our chief architect does a lot of stuff with GraphViz, and he said, well, I like your picture, but I want to tune it. Can you just give me the GraphViz that you produce? And then he'll tune it. So here it is, expanded with all the tabular data from the query result just in a file.
And all of the styling is also included in that dot as well, right? There's no sort of additional CSS or anything that's needed.
We have some fixed CSS, and like we added it so that it just kind of, you know, shows you just the match statement, you know. But then if you click on it, this is content editable. So I could say, well, instead of making the shape be a box, make it a circle. And carriage return, and now I get a different diagram.
Oh, neat.
Are all in there. If I come in here and say, and like I said, GraphViz is an old program, so I think this rankdir is just something they thought of one day and put it in, and there's LR for left to right and TB for top to bottom. Let me show it top to bottom.
Oh, neat. Right, because GraphViz is typically used for more flowchart visualizations, I think, right?
Yeah, you know, they have layout versions that try hard to do bigger graphs, but they don't have the interactivity of Neo4j's browser, where you say, well, let's just get something and then incrementally grow it. So we're more batch here. You know, we get a screen at a time, but then you have this kind of drill down. Oh, let me see this for service traffic reports, or all the ways we connect to programs or something, that drill down thing. And that's so classic old school web design. You know, there's a little bit of JavaScript in here, but not much. It basically is server turns around. And that just, you know, there's a tool building thing that I learned a long time ago, is if you want to make tools to help you debug your system, the tool has got to be simpler than your system, you know, so that if you see something that you don't understand, you can't worry about your tool. You have to worry about your system. And so so there's some real, let's see, stop sharing. There's some real effort here to keep it simple. I mentioned when we went from using, and I don't want to bash any of these systems because they've all been very helpful. Ruby on Rails was a way to get something up quickly, and then it got better when we made it simpler. And so what I'm interested in is a few little handful things, like the way we handle provenance and the way we approach modeling and so forth, is things that I would like to push on just to find a way that is simpler and more robust in an environment where the data keeps changing, you know, where you're watching a company grow. And this is, I'm lucky to, like I say, I'm proud to still be a programmer, and I program in a company that's healthy and growing, and you know, is very much about how computers work. And so I'm watching my colleagues do their job in a sense, and want to be there to help.
And you've open sourced the visualization piece of Dorado, is that right? So is this something that I could point at Neo4j?
I was showing you the that was running the open source version, and so I was up early this morning. You know, we put that little fade thing in yesterday, and I was up copying it over and deploying it to, you know, and that's in a new relic, all one word, is a GitHub account. And you can find it in there, and it will run. There's two things you know, if you just want to duplicate what I've done, you can get that that browser up and point it, you know, with an environment variable at your own database, and it will try to show you things. It might be looking for source tags on your relations, and that won't work. But you know, you can try it and get the GraphViz stuff. So you have to install GraphViz, but there's kind of make it simple instructions.
And we'll put some links to the
movie would be able to do it, but
okay.
The building part, that's another story, and you know, how we do that. Well, you got to get a Neo4j up and running, and that's always a little tricky, I've found, and that problem is solved beautifully with Docker. You know, I just go get a you know, a Docker image and load a handful of things into it, and you know, so let me show you what that looks like. Screen share again here. Well, I am screen sharing. Oh, you're helping me screen share. Is that right?
Yeah, you still need to just share the screen. I'm just
got it.
Controlling whether you're the presenter or not.
We are a team here.
Otherwise, we are invisible if we talk.
All right.
So, but while you're sharing that, it might, one thing I guess which we talked about before, which might be interesting to share with people maybe after this, is how you went about building your modeling, your graph model. So maybe after this we can look at that.
Well, this is another one. I said this one I just did on my own, just for the purpose. I wanted to have it here for this demo. So that's in GitHub, Ward Cunningham. And I'm pulling the word context out of Eric Evans' context stuff. But this is how simple the Dockerfile is. And I just, I start with Neo4j. I'm a couple revs back, but with curl and JQ is a utility that'll munge JSON. And I build it up as read-write, and while I'm still building the Docker, I start up Neo4j and run this load json.sh. And here I just mention 4 different sources. So I go to definition of the sources and pull out that information. When I'm done, I make it read-only by just messing with the config, and it's deployable. And that's what I have deployed right here. So if I say, you know, show me all the manager relationships. Yeah, here's a bunch of managers. Fake data, mostly managers of other people, but also managers of projects. If I say, what sources do you have? Well, sources are attached to relationships, and these are the 4 sources. Now in my at work data, that'd be 35 different sources, but this is all out there. And this is a URL that you can use today. I'm just happen to be running it for myself, and I made it public because it's read-only. I don't think you can break it, but if you know how to hack it, please don't hack my machine. I'll just say that much. And you know, mostly because I want to show that it's easy to kind of get this stuff going. And then the browser version, which we were peeking at here, is looking at that database. Again, just on a different port, 9292. So you can probe for today at least, and look around and see what's see what's going on. Try clicking some things. The source is, you know, this is me as an investigator building an observatory in support of my colleagues who are all architects, and so in that spirit, my company was happy to allow me to open source it. They did ask. They said, "Well, what's in it for us?" And I said, "Well, it's a chance for me to meet people who are interested in the same problem." And you know, that's one reason I'm glad to be here today. I joined the new sharing place community site, and you know, gosh, I was there for, you know, less than a day, and I met Mike Morley, who does something quite like this, and does it more real time than mine. I do it as a batch 4 times a day, and call that pretty real time for the kinds of things I'm looking at. But as we depend upon it more and more, we'll find things that we might like to we might like to be more interactive than that. It's tremendous growth opportunities here is what I would say. It's been. I like to tell people, you know, if this is all you could know about Neo4j, you know, I know this much about it. There's so many things going on that, you know, are just not the problem I've picked up. But there's plenty of people working in that space, and I think that means it's a tool that's going to be with us for a long time, and getting skilled at it is worth the effort.
Cool. Will and I have shared all those links that you just showed on the chat. So if anybody wants to play around with them, can find them on there.
Yeah, so we'll have a little Stampede here, and I won't be able to demo anymore. No, I'm sure about that.
So you mentioned you're interested in some more sort of interactive features. I guess what's sort of next on your list of the features to add to Dorado?
Oh, that's, you know, it's always the next data source. You know, the thing, you know, there's something here, and what connects them, and you ask around, and well, you know, it's in a spreadsheet someplace. What? It's in a spreadsheet? Okay, I'll read your spreadsheet. Only until you come up with a better place to put it. I'll tell you everything that's wrong with your spreadsheet. So adding more sources of a wide variety as I get further and further from the mainstream, the sources are more sketchy. But like I say, we're a growing company, and you know, it can't stay sketchy and allow us to grow. So I feel I'm really kind of working on enabling the future growth of our company.
What's the most difficult source you've had to work with so far? I'm curious.
Oh gosh. You know, there's APIs that I'll talk to that are designed around solving a problem that is different than I do. So it's hard to get out of them a list of all the questions I could ask, and then having to go through and ask all the questions that I could ask. You know, it says, well, you know, we'll tell you all about a service that's running. Oh, well, how many services? What are the services that are running? Oh, that's a hard query, but we'll give them to you maybe 100 at a time. Oh, okay. So now I have to ask for 100, and the next 100, and the next 100, and then I have to go through each one and ask. And you know, that's pretty tedious, and it takes a long time. But I run it in on a server and a Docker, and it just takes a long time. And if there's one that is rate limited, you know, people say API first, you know, but then they make their APIs crippled so that you can't abuse them. And I'm sort of an API abuser in that sense. You know, I don't want to just use your API. I just want to suck everything that I care about through it. And that is the thing that makes it hard. But, you know, when new projects are coming up, I just get involved with them and I say, hey, this matters for me. And they say, oh, yeah, I think we could do that. Yeah. The other thing I think is that makes it difficult is sometimes it's algorithmic. You know, we have a utility we use that will check a repository against a, you know, I don't know, an unbounded list of checks. And as we were doing some major work a year ago, they said, well, we added 5 new checks to that. Could you run that for every source code repo for every team for all of our products? And I said, sure, you know, and it turns out it takes a long time and it's a little brittle, and, you know, it pounds our source code repository pretty hard, but, you know, it works and it provided value, and the tool produces its own report, but, you know, there's no way of getting an overview. So I said, well, I'll just load it into the graph and give you all the overviews you want. And that was a case where it was an architect who was concerned, and he said, oh, okay, now that I have the data, let me customize some queries that'll be organized to the way I work. And so that was a nice collaboration. I like it when that happens. The other thing that in an incident situation, when things aren't working well, you might want to know, how are things hooked up at the moment? You know, because maybe something changed 10 minutes ago and now, you know, things are backing up. And if I run every 6 hours, that's like old news in that situation. And so I think we would like to, you know, pretty much everything in our data center runs on streams now, and I would like to be streaming based. But then, you know, there's something simple about starting from an empty database and building it up from scratch each time, because I have nothing. I have no information in there that needs to be preserved. I get it fresh every time. If something disappears, it's gone. I don't have to worry about removing things. And so I need to understand how live graphs are maintained. And I'm sure there's no simple answer, but I'm sure it can be done because I know people do it. So that's a direction for me personally, because there's some sources that would be more valuable if they were more up to date. They're rare in the case, but there are some.
Now, another project you've been working on is of course the wiki and federated wiki. Would you like to speak a little bit about that and maybe how you've used Neo4j with that project?
Yeah, it's I've been thinking about this for a long time, that you know, my wiki was pretty successful because it was a kinder and gentler time where you know, the net was filled with computer programmers who just wanted to get better at their job. And so we basically launched what's now called Agile, you know, with people relating their experience and talking about that. And they did it in my original wiki. 5 years into that experience, the encyclopedia people kind of caught on and used our experience as a guide, and, you know, changed a few things and made it better for their purpose. And then they went for 10 years kind of convincing the world that this was high quality information, you know, so that's 15 years. But through most of that, I'm thinking, they is a centralized source. I had too much power, and Wikipedians have too much power. They have a lot of rules. I had rules. I said, don't tell us what we ought to do. Tell us what you did. That was kind of my rule. Their rule is, don't put anything in there if you can't defend it with a citation. And you know, it kind of keeps the peace. But what if you want to make wikis where you're exploring something where there isn't a source, where you're hypothesizing or suggesting or something like that, something that's much more dynamic, like on the frontiers of research is what I would often think about. You know, we have a lab with 15 postdocs in it, and they're doing, you know, amazing things with genomes, and they're trying to cooperate with another lab across the, across the world, and they're willing to share some stuff, but not all stuff. And the idea was to just say, well, everybody gets their own wiki. Maybe every team member, maybe every team, maybe every lab. You know, that wikis are cheap. But the way you make that isolated thing feel like it's one place is by just doing enough JavaScript that when you click a link and that link is on somebody else's wiki, it just goes, gets it, and shows it to you. At the time, I was modeling after work done with Code for America, where they said, well, you know, we take all these crazy databases and just turn them to JSON, and then people can understand them. So I said, well, I'll make a wiki based on JSON. And so it's all JSON. And we said, every paragraph can be a different type. It could be, well, it could be just plain text, and we call it a paragraph, or it could be HTML, or it could be MathJack's scientific notation, or it could be a data set, or it could be a visualization, or it could be, you know, so there's probably 40 different kinds of things in federated wiki, and I talk about it as a data wiki. And I could go on for 2 days straight about things we've learned in 6 years of building plugins and using it and monitoring and scraping it. You know, by the way, it's easy to scrape, you know, because it knows what it is. It's structured. It's not like scraping the web. But let me just show you I showed that thing where I said I'll pull the 4 different sources. I just made a wiki that was about pulling this data together, and let's just take a look at that. And this is, let's see, I've been browsing through here. This is, you know, this is a context. Context is a word I get again from Eric Evans. Context.asia.wiki.org. And if we go there, it says, this is about data in context. And I can come over here and it says, well, we can look at an organization chart. Let's just get started. Or we can talk about the data. If you go down here, you can say, well, this is about the data. And I talk a little bit about it. And the live El Dorado demo, this is what this is, if we come down here, it'll tell us that this is recent. Let's see, if I click wiki, it'll give me the history. This is since 2 weeks ago. So this is a new page. That's when I said, well, I better get something live to demo this. But I had the data, an organization chart. This is coming from some other source. This is a plugin called a JSON. And I say, well, if you put JSON, you put a JSON paragraph here, then it creates an API that somebody can post to. And so this said it was last posted 4 hours ago after 24 hours. So once every 24 hours, there's a post to here. The last post was 14 kbytes. And then I go through here and I say, well, all right, so I have this data. Here's some more data. This is the source code. This is the second thing. This is from here I can go to the third thing. So they're all laid out in this format where I'll have, this one was 24 minutes ago. This was 74 minutes ago. And so this is staging of this data. Now at New Relic, I have a system like this, but it's done completely differently, and I do more pull, and it's a Rube Goldberg machine of some sort. So I said, well, if I wanted to do over again, how would I do it? And I do it like this. And one thing I spend a lot of time is just proofing the data comes in. So here I say that this is a plugin that's called the meta model. Oh, I see, I haven't bothered to write any documentation on it yet, but it says it's going to be an array of things. The things are going to be nodes. The nodes are an object that has names and emails and a manager. If I hover over these things, I don't know if you can see it, but it says 136 elements. So it says there's 1,000 max, you know, and this is my validator, and I can look at samples. So it says, oh, here's T. Ganderson at email.com was an email. Then I tack onto this, I say, oh, here, by the way, is the cipher that I would use to take this metadata plus these 14 kbytes and put it into a graph. So I explain is the thing that has these properties about dates and when, and I create an object, a node called S. And then I take the JSON all apart and I pull it apart, and then finally down here, I'm doing merges and that. And oh, I say here, this employee has manager M. And so I merge that relationship and I add, oh, and the source of that data is the name of S. So this is really pretty neat. Now, as I get, like, here's a doubly nested one. Oh, my validator is complaining here. It says, oh, the validator gave up on this one. It was too complex. So that's a validator that's not finished yet. But, you know, a lot of things in this wiki are not finished yet, but I get to work with things when they're incomplete, and that's powerful. So this is going through it. Some of them, William had to help me figure out how to do this one, where I had case statements, you know, different kinds of sources or communication paths and a data flow needed to be done different ways. And so he gave me a tip on how to do that. As he nice suggested this alternative. Thank you. And this is, you know, so you can see my learning here in just figuring out how to do this. Now, of course, now I have a specification that I can check. And in each of these cases, if I hover it over, it'll show me examples. And I have a target that I want to generate. So I think what I'd like to do is go to where I have a specification, and from that specification, I generate the cipher that will save it. And I have 4 examples worked out here that I could start with. And that could be kind of a project. It might be, I suspect it'll be too specific to be generally useful, but it could be a great solution to this problem. But more importantly, it really uses the data properties of federated wiki. And the cool thing is, as I slide around in here, I've got, again, this kind of drill down thing. If I click up here, this tells me a little bit of the history, mentions other places. You know, so the first page is always like, who are you and what are you giving me here? So that's federated wiki.
And so this drill down is sort of keeping everything in the context of your journey through exploring this data, I suppose.
Yeah, and this is interesting. This is, here I'm referring to another project. And it says, oh, I pulled this page off of another site. It appears on this site, so I can pull it up from that site. And here in the history, you can see, oh, this is when I pulled it. That was 8 months ago. But now when I click a link here, I started on this blue site, and now I'm kind of on this turquoise site. And as I move around, it just, the little border here tells you, oh, you've left this site, you're now on another site. But this is how, because pages can be moved around so easily. If I get off to a page, this page isn't on this site. But if I want it on the site, I could just click this right here and say, bring it locally. And now it is on that site. Of course, it said, oh, I tried to write it and you're not logged in. So I saved it in local storage. That's that yellow warning. So there's a lot of machinery here. But I very quickly went from a few pages to 60 pages. Let's do that again slowly. If I come back here, I have 23 pages. And I said, well, tell me about Ward Cunningham and about the El Dorado project. And I went to another site, and it read in that site map and says, now you're at 60 pages. Well, I could probably get from anywhere to anywhere, you know, in this wiki. For example, I could say, how to wiki. And here's a site about documentations. I'm up to 150 pages. How about the federated wiki? There's a little document about, oh, they say one idea is copying. We copy all kinds of things. You know, so now we're 179 pages. The neighborhood that you're browsing in just keeps growing. Now, does this feel a little bit like what I'm doing with browsing Neo4j? Well, it feels the same to me. This is one that it's an editor, it's a wiki, whereas I didn't want a wiki. And I kind of wanted a wiki, but I said, well, if I do it all with wiki at work, people won't understand it. So I'll do it with just a simple Sinatra program and be very Neo4j focused. But all of this is about navigating sprawling information. And so this is a strategy that we're developing, and I like the idea that I can move things back and forth from or to different wikis. I actually scrape the entire federation 4 times a day and save and have a download. I should mention this to don't want any of that. I was trying to search for well, I know it's over here. So if I say find me the download, search index download. Somewhere in here, graphs. Oh, here, I'll give it to you. I'll give it to you as nodes and arcs. This will feed right into Neo4j and batch loading. So this was my first experience. It did, you know, this didn't turn out to be great because it wasn't a perfect match, and the data was too sprawling. But you know, this was me learning it. And I will mention that this is a connection, as I have open source stuff that I do in a community, and I have stuff that I do at work in a different community, that I find that I can drag stuff back and forth, and it is a very healthy way to stay an engineering-oriented person. I learned by programming, and this is what I've learned.
Cool. It's really interesting. I guess we should probably wrap up in the next couple of minutes. We've already gone over the hour.
Well, I'm tired of going over. A little. Thank you for your patience.
No, yeah, it's really interesting. I think people have really enjoyed your presentations, and thank you for taking the time to show us what you've been working on. To please the YouTube overlords, if you enjoyed the talk, don't forget to press the like button so that other people can find it. And I'll post a link to the community page with Ward's project so that you can ask any questions if you think of them after we finish the chat. And I guess yes. Also, thanks to Will.
And I will be in the community, so probably that's a good place if you say, did you think of this, or here's something else you ought to be paying attention to, or how does this actually work? I think in the Neo4j community, or on the issues on those 2 open source projects.
Cool. All right. Great. Well, I guess we'll wrap up there. So thanks everyone.
For coming.
Thanks. Cool. See you all.
Cheers, folks.
Bye.